What's going on, guys? Kotax here. Today I have a brand new video for you guys. So this is part three in the maze solver series. So today we will be probably. I know I said I would finish it in this video, but I think it's gonna take one more video and then another one where we might clean up the code depending on how messy it gets. Cause I don't actually I know how to go about it because I know the whole like algorithm like in my head, but like what approach we're taking. And yeah, we're gonna do probably some coding, but it'll be more theoretical stuff, figuring out how breadth first search works. But on the screen right now, I am showing the command I use to set up a local host. So when I'm going to like when I show all my when I'm showing the website, you'll notice that I'm actually on a local host instead of firing up the HTML file. And there isn't really any particular reason I do that in this case, because you could just, in theory, just double click on the index.html file. But I'm just used to it, and it just, if you want to expand this website, it just makes it easier to have more of like a proper interactive like functionality that you would if you're hosting it somewhere. But yeah. So how to set that up? It never crossed my mind, but you have to run this command python 3-m http.server. And if you search it up on Google, you can figure out how to bind it to different ports. So you'll notice that it's at localhost port 8000. So you can definitely figure out how to change it to 3000 even and bind it to your router IP, like your IPv4 address. So then you're working on it on your computer, and then you can access it from other people's computer, like in your household that are connected to the same internet. So yeah, that is totally a possibility with this. That's what I like about it too, that you can debug it, especially when you're working with like a chat apps and stuff. But yeah, run this command in the directory. So cd into the directory, and you will get a localhost server. I apologize I didn't show this earlier, but yeah, that is it. So today, basically, the plan is we go over breadth first search. So breadth first search, as you can see in this Wikipedia article, I will be linking in the description, is an algorithm for traversing a tree. So basically, we're going to convert this whole grid, this 10 by 10 grid, into a tree like this. And I'll give a few examples, so don't worry. Um, so basically, this is an animated example of what's going on. So the black represents visited, the gray represents to be visited, and the white represents unvisited. So you can see what's going on. And so when it starts at A, so I visit A. So, okay, before even all of that, I actually have to create a queue. So, kind of like a line. Like you're making all these nodes stand in line at the ice cream shop, right? So, how this works is basically have your. Is my audio still working? I clicked all these buttons on my mic by accident. Okay, we're still good. So, basically, the situation is, let's say I have node A over here. I visit A, I add all of A's neighbors to um, the queue. So the queue is basically, excuse me, the queue is to be visited nodes. So I add its neighbors, and then I visit the next node, add its neighbors, and that way I can traverse through the whole tree by going to a node, adding its neighbors, and then once I'm done, it'll have no more neighbors, right? And basically, breadth first search in our case will be only going down the tree. So we'll be starting at that parent node, which is node 1 right here. So this red node right here. And yeah, that's basically it. I don't think there's anything. I'll be obviously drying it out right now, this as we speak. So let me hop on here, get this out of the way. So I have this little thing fired up. So let me full screen this and see it a bit better. So let's say I have a 3 by 3 grid. So this is node 1. And okay, before we even draw nodes, let's just grab this color. Let's make a wall here, and we can make one more wall here and one more wall here, right? So basically the situation is this is node 1. This is basically our parent node, our root node that we were looking at in that Wikipedia article. So basically we first of all we label all of these boxes, which I've been calling nodes this whole time. So let me just do that. Okay, so I labeled everything. So basically, we have to convert this into this tree that we were seeing in the Wikipedia article. So into this tree right here. So how we do that is basically um, we can basically ignore these walls, so to say. We could kind of just cut these off, and in our programming, we could just put like -1s instead of them, right? And then what we can do, we start at our parent node. So we start at 1, and then we look at its valid neighbors, which in this case is only 2. It can't go to 4. If 4 wasn't a wall, it would be able to go to 4. But since 4 is a wall, we've replaced it with a -1, so it's not a valid neighbor. So we go to 2. 2 is the possible neighbors of 5, and then 5 has the possible neighbors of 6 and 8. But this is the way we're going to set it up. 6 and 8, and they both have the possible neighbors of 9. Now, this is how we're going to assemble our tree to make breadth first search even easier and quicker. In reality, it's really 1 is has the neighbors 2 and 4, but we're just going to ignore 4 since it's a wall, right? So there's no point in focusing on what 4 is. Sorry. So we're just going to 2, 5, 6, 8, 9, 2, 5, 2, 5, and then, sorry, I got lost. 6, 8, and both of these go to 9. So basically, the whole thing with breadth first search is I have to go down this tree to get to the endpoint and find the shortest path. And then when we have bigger and bigger trees, finding the shorter path is more difficult. It may look really simple here, but again, in a 10 by 10 grid, not so easy with only 3 walls. So yeah, I hope that kind of explains it. It'll explain it even more as we're coding it. But yeah, so just stick with me here. So that is that. Let's move further. So basically, let's go with that same grid. Let me keep it in our kind of viewing range. And we have to figure out how we can represent this tree. So let me write this tree a bit more cleaner. So we had 1 is neighboring 2, and 2 is neighboring 5, and 5 is neighboring 6 and 8. And those two are both neighboring 9. So how do we represent this tree with code? Because that's what we're traversing ultimately. So pretty much the best way to do this is an adjacency list. An adjacency list is basically just a dictionary. So you have your key, and then the values are the neighbors. So you have your key 1, neighbors are 2. You have your key 2, neighbors are 5. Right? You have your key um, 5, neighbors are 6 and 8, and you get the point, right? So we're going to use this dictionary to basically help us traverse through. But instead of having these nodes, we're probably just going to have coordinates. I think that will be the best way to do it. So coordinates of, where the next one is. But we'll get into the logic a bit more into the next video. But first, we got to set up this whole matrix and the adjacency list in this video. So we'll hop onto our code, and basically all I've done is I've added this extra variable called len at top is just 10, um, because these are all hard coded, and in the future we might want to change these to work with different sized grids. So yeah, um, yep. Okay. So next, what I wanted to tell you, I added this on-click event for uh, the solve button that's on our web page. So let me just hop on our web page so you guys can see it in the bottom right screen. This button right here, this one. So yeah. And yeah, that's pretty much all I added. And yeah, let's just go to this file and add function solve maze. So basically, I think the first thing we should do is we should convert this whole maze into a computer 2D array. And that just to absolutely visualize how this is going to work. And we can figure out if we want to do this a bit more just straight getting from the HTML elements to an adjacency list. But first, we need to get this. I think the best way to do this and the simplest way to do this is get it in an array. So we got to create a var maze, and that is just going to represent the whole maze. And we're just going to do four. I don't use lets, but you know what? Let I equal 0. I is less than len I plus plus. And basically, what all we have to do is simple. I think it's because of ES6. So thank you, ES6. All I have to do to create an empty array filled with zeros is I just have to do array of size len. And so basically, len is 10. So in each index of this maze, I'm basically putting an array of size 10 that is filled with zeros. And yeah, that's literally that easy. And now we got to map out this whole maze, that whole what we have here, like these whites and everything. We got to map out this maze onto that whole situation. So we could approach this, I think, a few ways, but I think the fastest way is we have to go through, have a for loop that is gonna go traverse through the whole maze. So for var I equals 0, excuse me, I just had to crack my neck. So for var I equals 0, I is less than. Here is where we make a decision. Sorry, I just have to think about, because this is kind of, it's not even, you know what, it's not important. Let's just say I equal to 1. So I'll tell you why. I was just thinking about that for a second. So basically, this is going to traverse through all the HTML elements. So basically, it's going to start at node 1 and then go to node 101, but not including 101. But we need a few variables too. We need a variable var, I think we should call it row count, var column count, and we should have var count, which is basically the actual node value. So I think that is the easiest way to set this up. And basically, we just need a simple if statement checking if the current node, so if document dot get element by ID um, node I dot style dot background color equals wall. So if it's a wall, basically all I wanted to do is I want to set this directory in the maze. I want to set maze row count, call count, and I'm just gonna have negative ones representing the maze, representing walls in the maze. Sorry. And then otherwise, I'm just gonna have this maze, this element right here at these coordinates, or else I just want it to be the node value. And then basically here, all I have to do is I can do call count plus plus, and then what do I do? Now the question is, how do I increment? So if call count equals the length, since it's a square, we could just do row count plus plus, and then call count plus plus. Okay, yeah, that's fire. So that's basically handling all our rows, and then at the end of the iteration, node val plus plus. Okay, so we basically have our whole maze there. Now we could just console.log the maze. So let's just hope it works. So let me go to this screen recording software and just get a little bit of a bigger view. So let's go to the console and let's draw a few walls. So basically, we can test it really easily. If it prints out the second element of the first row is -1 and the first element of the second row is -1, it works. So we click solve and we look at it, and let's just take a quick look. So there seems to be some type of error. So the second uh, index actually has 101 elements in it, so that's an error. But on the second hand, so let me just look at this thoroughly, and I'm just gonna just pause it so I don't waste you guys' time because this video is already 16 minutes. Okay, I didn't even have to, I just paused it and restarted like right away because call count, once you increment the row, call count has to equal 0. So yeah, that was bad error for no reason. So let's try that again. Solve, and now you should see a proper array with these proper whole proper notation, and that is exactly what we want. So let me hop back onto the code and let's just, we don't need this, just comment this out. Okay, so now we got to convert it into an adjacency list. So var adjacency, I'm just going to write edge list equals, it's a dictionary, really. It's really that easy. And then, second of all, we could approach this a few ways, but I feel like we should have uh, an array storing possible moves. Possible moves. And here's what I'm saying. So let me just go to this drawing app. I really do recommend it. It's really good. Um, so the situation is, since Code Talks has a green logo, I gotta go back to green. Sorry. Okay. So we need to create an adjacency list, and but we need to figure out how the moves are gonna work. So if I have an array, like in programming, when you have an array, let me use this. So in programming, when you have an array, so let's say you have a 3 by 3 array in programming. So the indexes aren't 1, 2, 3. It's 0, 1, 2, 3. And then that kind of makes sense. But going downwards, it's also 0, 1, 2. So the origin is actually over here instead of over here. Instead of over here, which may confuse some. So we got to be a little careful. So basically, to go up, we have to basically subtract 1 from the y coordinate. To go down, we have to add 1. To go right, the right is normal. And to go left, like this. So we got to implement this into our code. So the possible moves we're going to set is everything but diagonals, really. So possible moves can be -1, 0, 0, and I just realized I'm not in the thing, but yeah, this is all I added. So error number one, this is a array, not a dictionary. But yeah, those are our possible moves. So basically you have up, no, sorry. You have left, right, up, down. No, down, up. Left, right, down, up. So yeah, that is basically going to help us just kind of gauge our possible moves. So now we just got to traverse through this maze thing we made. And the reason we didn't directly take it from the HTML is truly because I think it's just easier to deal with the maze array. So I plus plus, and then for var I equals 0. Why did I use I again? Okay, so basically these two loops are going to traverse to that whole situation. And basically in these loops, we're just going to fill in the neighbors. So first comes first, we got to check if it's a wall. If it's a wall, we just got to pass. So if maze ij equals -1, I just want to skip through this iteration. This iteration, it does not really matter. We're just going to leave it out. So now if we're in the important areas, basically we got to have var current node, and then to store the current node, which would just be uh, maze ij, and then its neighbors, var neighbors are just an array that we're gonna TBD, like to be determined. So since we have four possible moves, moves dot length. Is it dot length? I always get confused in JavaScript. Let me just quickly test it out. Okay, it's without brackets. So var count equals 0 while count is less than possible. What did I call it? Possible moves. Possible moves dot length count plus plus. Nice. Okay, so this will basically go through the possible moves. So I think so, it just makes sense to create new row. So basically, the new row is basically a potential row that we're visiting. Um, we're just gonna do. What are we gonna do? We're gonna do possible equals possible moves. Okay, wait. Instead of ij, I'm gonna write row and call, just to be actually since we already did I. Ah, no, it's good to have code that's readable. So okay. So new row will be possible moves count. So that will return array number 0 plus row. What? Plus row. Okay, yeah, that wasn't so bad. And then the new call will be number 1 and call. So these are the new rows. So first we got to check. So actually, um, got this whole thing ready. So basically, we gotta check if it's inside the boundaries of the maze. And if it is in the boundaries, we're gonna consider it a neighbor. And if it's not a wall, we also have to check if it's a wall. So I'm gonna type that out right now. So if it's a wall, then I want to do this whole situation of adding it to my available neighbors. And I'm just gonna do this, and I guarantee you, definitely did not switch the screen. Sorry about that. But yeah, all I did was if the new row is greater or equal to 0 and the new row is less than maze.length, what's the situation? Uh, I'll just figure this out in a second. But if the new row is greater, so if it's greater or equal to 0, then and new row is less than the maze length, so we have a variable maze, and always forget my brace brackets. And if the column is from the top downwards to the boundaries, then only then we go to the next condition, which checks if it's a wall. If it's not a wall, then I'm going to count it as a neighbor and push it into the adjacency list. So that basically, ladies and gents, finishes off the whole adjacency uh, business, or actually, close, close, ladies and gents. So now we gotta officially, at the end of this iteration, we gotta officially add this. Are my brackets not lining up? What's the deal? Like, do I have too many brackets? Or okay, wait. So this if's brackets are this. This if does not need a bracket, and this goes right here. I think that fixes it. But yeah, we gotta officially add this whole thing. So to the adjacency list. So adjacency edge list cur node equals neighbors. And you know what? Since we did all of this hard work, let's just look at what it looks like. So I'm going to console.log the adjacency list just for y'all, and then we'll call it a day. This video is 28 minutes already. Time flies when you're having fun. Okay, let's hop on the website and let us do this. So if I add a bunch of walls, okay, and I click solve, we have an empty adjacency list. Let's go. That's exactly what I was going for. Okay, what's the deal? What is the deal? Proto object, proto. Let me just so if I click solve, you have an empty adjacency list. Awesome. Thank goodness we tested that so we can figure out what is wrong with this whole situation. So basically we're traversing through the columns, makes sense. If it's equals -1, then okay, wait. First we should console.log maze just to make sure that works. So we got a 10 by 10 array with no walls. Okay, step one is good. Okay, then we have a row that checks if there's negative ones. So there isn't any negative ones. And then we go to current node equals maze column. So I don't think we need a console.log. I think we're good on that. Let me just check. I think I should probably just do instead of even though it will not make a difference, we should just do maze.length and maze.length. You know what? Watch that. Watch this make a difference. It can't make a difference, but let's say hypothetically. Okay, yeah, it didn't. And then let's say the current node possible moves. So I think the error is somewhere here. So you know what? Wait. This for loop, after this for loop, I'm gonna set it with the list of neighbors. So edge list. Okay, wait. I'm just gonna print out console.log true. So it didn't print out true, and it didn't print out a proper adjacency list. So what if I print out edge list one? Undefined. What do you mean undefined? Wait. Timeout. Timeout. Console.log per node. Okay, I'm just gonna pause this because I don't want to be over 35 minutes, and I'll be back. Guys, I am sorry for making this mistake. It's just supposed to be row over here. You guys must be literally screaming through the screen, saying, "Bro." Okay. Now, if I go to the maze solver, it should work. I did not test it, so if this doesn't work and there's another bug, that would be quite sad. What line is that on? Means I.length property of undefined. Yeah, because I is not a value. Come on. Why? Why did I have to do this? Okay. Now, if I did it properly, and I'm just gonna print out console dot log console.log add list. And now, ladies and gents, I'll click solve. Are you actually? Why did I write call? Why would I write call? Why? Okay, this is the one. This is the one, I guarantee. Let's go to the console and solve. Yes. Yes. Okay, wait. Just to double check this whole thing's working, I'm gonna print out one. Wait, this prints it out. I want to print it out here. Okay. So if I click solve, it should give me an array of 1, 0, which is row 1, column 0, and row 0, column 1. Awesome. So that is it, guys. That's the end of this video. I hope you enjoyed, even though we fell into some errors. That's still super fire. Thanks for sticking along with me. Please like, comment, subscribe, and next video we will finish this up, and then we'll take this project even to the next level, even continue after that. Anyways, see you guys. Thanks for watching.